Hi everyone, just going to go over question 20 here. This was in section 1.7. This is a open top box, and it's kind of a classic math question in functions and later in calculus as well. So I thought it was a good one to sort of give you a full solution for. I'm just going to say up front that I'm not going to worry about B, C, and D here. They were fine questions, but they're not really part of the true solution to what we want to see with this question typically. So part A basically just asks us to express the volume given this information and given the fact that we're cutting these corners off. This is kind of an x by x little square, an x by x little square in each corner. So given that information, express the volume as a function. And so the height of the box is going to be the x that we're cutting off. Sort of when we fold this up, this piece right here becomes the height. And of course this piece right here becomes the height as well because we're folding these edges up. So this is our height, what we would call typically our width or our length. I don't know, it doesn't really matter which one you want to call it. Length here is over here, and this is the width or the depth right there. So volume is usually length times width times height. I happen to write it all in reverse order, but of course that doesn't change anything. In part E, and I didn't realize that it took all the way to part E to get there. It's just asking us to find the volume given, find the dimensions given this specific volume. So in that case, what you're asked to do really is plug in the volume and solve the rest of the question. So what we've been working on so far is solving equations that look like this. And so what we're looking to do with the question from this point is get to something that looks like this. 0 equals, and then cubic or quartic functions on the other side. In this case, obviously, it's going to be cubic. And so I've expanded this. X times 24 is 24x, x times negative 2x, negative 2x squared. Then multiply this bracket through this bracket, and that's the expansion. Subtract the 1820 over and simplify, and we end up here. Now, in order to solve something like this, what we've been doing is factor theorem followed by synthetic division, or factor theorem followed by long division, whichever, again, you're more comfortable with. I'll tell you that this question, because of the numbers, I think the book actually intended you to just graph it and read off a graph. Normally, I would think you should be able to, if I gave you a question like this on a test or on an exam, I would make the numbers work out a little bit more nicely so that you could then finish it up. But as I kind of go through it here, I see a common factor of 4. Anytime I'm factoring, I'm going to look for that common factor first, even when I'm going to use the factor theorem, because then again, I'm going to be working with smaller numbers and it'll just be a little bit nicer. So the common factor is 4, and then the second bracket is what remains after I factor out the 4. Looking at this number, I'm looking for factors of this that when I plug into the equation give me a 0. Happen to get lucky. I can see right off the bat obviously a 5 is going to divide evenly. I don't know too many other numbers. Looks like a 91 will be another factor, and that's probably about it. 91 divides 13 times 7, I guess. So 5, 7, 13 are my possibilities, it looks like. The 5 did work, so that was nice. And so P of 5 is 0. And then I can use synthetic division to simplify down to this expression here, x squared minus 25x plus 91. Okay, so we have the factors now. This second factor does not factor further. I'm looking for two numbers that multiply to 91 and add to negative 25, and they don't exist. And so my only solution to this, when I get back to the fact that 0 is equal to that, I get 0 equals 4 times x minus 5 times this term, this expression here. And so the only value I know here that's going to give me a 0 is 5. So this, when x is 5, is a 0. 4 times 0 times whatever this happens to be will be 0. Again, because this didn't factor further, I don't know any numbers that work nicely there that will give me a 0. So that means that 5 by 5 centimeter squares are being cut out and kind of going all the way back to the beginning. If I take 5 centimeters off each side here, I'll have 26 left. 5 centimeters off each side here, I'll have 14 left. And so my dimensions are 26 by 14 by 5.